Imagine a future where machines don't just serve us, they anticipate us. Where humanoid robots walk among us with expressions, instincts, and the ability to learn faster than we can teach. A world where artificial intelligence doesn't just react, but decides. That future? It's no longer a concept. It's arriving faster than anyone expected. Welcome back, guys. Alfie here with all the latest AI robot developments of the week. We're diving into this week's biggest AI and robotics breakthroughs, and I'm telling you now, we are not ready for what's coming. From robots showing human-level skills to AI systems pushing the boundaries of what was once considered impossible. These updates will blow your mind. You're watching the AI Nexus, and this is your weekly reality check on the fast-approaching future. Let's jump in, because the machines are moving and the world will never be the same. LimbX Dynamics has just released a stunning new video of its humanoid robot, the CL3, and it's making waves across the robotics community. This isn't just a basic test clip, it's a full showcase of what next-generation full-size humanoids can actually do in real-world scenarios. From the moment the robot powers up, you can see the difference. CL3 moves with a level of control and balance that immediately sets it apart. The video opens with the CL3 lying flat on the ground. Most robots struggle to handle this position, but not this one. It performs a smooth roll onto its side, shifts its legs, and then pushes itself upright with an almost effortless grace. This is a big deal. Standing up from a fully prone position requires complex coordination, torque management, and dynamic balance. Yet CL-3 handles it like it's second nature. What really grabs attention is how it performs full squats and waist twists without losing balance. You can actually see it stabilize and shift its center of gravity in real time, adjusting with every movement. When it twists its torso and rotates its legs outward, it's not just mimicking human anatomy. It's exceeding it. The leg joints rotate far beyond what a typical human hip allows, giving CL-3 incredible flexibility and reach for a humanoid form. That flexibility comes from a very deliberate design choice. LimbX has gone with a hollow actuator system combined with custom-built high-torque density actuators. These aren't off-the-shelf motors. They're specialized components designed to deliver smooth, powerful motion with a wide range of movement. That's why CL3 can perform agile maneuvers while staying balanced, even on one foot or during a squat. The robot's balance isn't just mechanical. It's the result of deeply integrated control systems that allow CL3 to react in real time. During one sequence, the robot twists at the waist, rotates a leg around, then lifts itself into a crouching position before standing. The fluidity of motion here is something that really highlights the synergy between the software and hardware. LimbX Dynamics seems to have cracked the code for real-world humanoid movement, not in a lab, not as a CGI render, but on camera, in actual motion. What's perhaps most exciting is that LimbX is pushing into the realm of humanoid usability. Unitree's latest humanoid robot, the G1, just pulled off something that's catching everyone's attention. It ran around 13 kilometers in a 2-hour live stream. That's right, a full 2-hour continuous run, streamed live for the world to watch. And no, this wasn't a carefully edited demo or a high-budget simulation. This was real, raw performance under real conditions. The robot kept a steady average pace of about 1.8 meters per second throughout the session, showing not just stamina, but also reliable, repeatable locomotion that many in the field have struggled to achieve. Now, it wasn't a flawless, non-stop sprint. The G1 needed 2 battery swaps during the run, which is expected given the energy demands of bipedal locomotion over such a long period. But that in itself is revealing. Unitree has clearly designed G1 for modularity and real-world operation. Swapping the battery and getting the robot back on its feet quickly is part of the broader goal: practical, sustained humanoid mobility. To put this into perspective, if the G1 kept that same pace, it would complete a half marathon, roughly 21 kilometers, in about 3 hours and 15 minutes. For a humanoid robot, that's an astonishing level of endurance and efficiency. Most robots in this class are still mastering walking steadily or balancing on uneven terrain. G1 just ran 13 kilometers like it was warming up. This isn't just a flex of engineering muscle. It's a signal that Unitree is dead serious about building humanoid robots that can function for long durations in real environments. Whether for patrol, delivery, research, or labor, having a robot that can operate at that level of mobility and endurance opens up an entirely new range of possibilities. And let's not forget, this happened on a live stream. There were no edits, no post-production illusions, just the G1 doing its thing in real time. That transparency goes a long way in proving what the robot is truly capable of. It's one thing to claim performance on a spec sheet. It's another to show it, live, with people watching every second. G1's 2-hour run might not make headlines in mainstream news, but in the world of robotics, this is a big leap forward. It's not about flashy tricks. It's about consistency, energy efficiency, and proving that humanoids can start to operate for hours at a time without supervision. And in that regard, Unitree just set a new benchmark. Haoran Gang, a researcher deeply familiar with the frustrations of building in the robotics space, just introduced something that could change the game entirely: Roboverse. If you've ever tried to develop or scale a robot learning project, you probably know the pain he's describing: juggling incomplete datasets, dealing with inconsistent simulation environments, and spending endless hours trying to patch together broken tools that were never designed to work as a unified system. For many in robotics, that's just the norm, but Roboverse aims to change that. Haoran points out a real problem in the field: fragmentation. Right now, robotics researchers often have to reinvent the wheel just to get started. One team might be using MuJoCo, another Isaac Jim, and another PyBullet, with no easy way to share code, results, or even benchmark fairly across platforms. And even when you do get a simulation running, it's often missing key features, riddled with bugs, or just not scalable. That's where Roboverse comes in. Roboverse isn't just another tool, it's a full ecosystem. At its core is MetaSim, a cleverly designed configuration system and interface that aligns the most widely used robotic simulators. The idea is simple but powerful. Write your code once and run it anywhere. Whether you're using MuJoCo, Isaac, or something else, MetaSim lets you plug in and go. That's a huge step toward unifying community efforts, much like what RTX did for real-world robotics data. It means less time debugging platform-specific quirks and more time actually doing the research that matters. But Roboverse doesn't stop at simulation. It also introduces the Roboverse dataset and benchmark, a large-scale synthetic dataset bundled with a standardized evaluation system. This is important because it puts imitation learning and reinforcement learning on the same playing field. Instead of every lab designing its own mini-world with its own scoring system, Roboverse brings consistency, scale, and high quality into the mix, making it easier to measure real progress and compare methods objectively. And here's where it gets really exciting. Thanks to the unified nature of MetaSim, Roboverse unlocks something that hasn't been easy before: hybrid simulation. Imagine combining the highly accurate physics of MuJoCo with the visually stunning rendering capabilities of Isaac. That's not just eye candy. It's a serious upgrade in simulation fidelity, and it has real impact on transfer learning. When your simulated environment better mirrors the real world, your models are more likely to succeed outside the lab. That's a win not just for research papers, but for real-world robotics deployments. Boston Dynamics just teamed up with NVIDIA for something that could redefine how robots manipulate the world around them. The two powerhouses collaborated to demonstrate Dexter AH-RGB, a new workflow for dexterous grasping that relies solely on stereo RGB input. No depth sensors, no special markers, just two regular RGB cameras feeding visual data into a highly trained AI policy. And the results? They're genuinely impressive. At the center of this demo is the Atlas robot, Boston Dynamics' iconic humanoid platform. But this isn't just about mechanical strength or flashy backflips. What's happening here is far more subtle and sophisticated. Atlas uses an end-to-end policy that's been trained entirely in simulation, within NVIDIA's Isaac Lab environment. And when they say end-to-end, they mean it. From raw RGB images all the way to precise finger movements that successfully grasp objects in the real world. The real kicker? This policy transfers zero shot from simulation to the actual robot. No fine-tuning, no post-sim calibration. Just load up the policy and it works, right out of the virtual world and into reality. That's an enormous leap forward in robotic learning and deployment. During his official visit to Zhejiang Province, Hong Kong Chief Executive John Lee Ka-chiu toured the headquarters of Unitree Robotics in Hangzhou on April 23, 2025. Unitree, renowned for its advancements in humanoid and quadruped robotics, is among Hangzhou's 6 little dragons, a group of innovative tech startups making significant strides in artificial intelligence and robotics. At Unitree's facility, Lee observed demonstrations of the company's latest robotic technologies, including the G1 humanoid robot. The G1 has garnered attention for its dynamic capabilities, such as running 13 kilometers in 2 hours during a live-streamed event, showcasing its endurance and advanced mobility. Lee's visit underscored Hong Kong's commitment to fostering innovation and technology collaborations. He emphasized the city's strengths in global connectivity, robust intellectual property protections, and a vibrant research environment, inviting Unitree and other tech firms to expand their operations in Hong Kong. The Hong Kong Special Administrative Region government has already initiated steps in this direction by procuring Unitree robots for testing and public engagement activities. This engagement is part of a broader initiative to strengthen ties between Hong Kong and Zhejiang, aiming to leverage complementary strengths in technology and innovation for mutual growth and development. Foundation Robotics is making a bold move in the humanoid space by going against convention, specifically when it comes to actuator design. Instead of relying on the widely used harmonic drives found in many humanoid robots today, they've chosen to build their actuators around cycloidal gear drives. It's a deliberate engineering decision that reflects a deeper strategy, designing robots that are not only strong and precise, but also easier to control and simulate. According to CEO Sankayet, one of the biggest reasons for this choice is the role cycloidal drives play in narrowing the sim-to-real gap. A persistent challenge in robotics where behaviors trained in simulation don't quite transfer cleanly to real-world hardware. Harmonic drives, while compact and accurate, tend to introduce compliance and backlash that's notoriously difficult to model accurately in simulation. This makes it harder to train robust policies that behave the same way in both virtual and physical environments. Cycloidal drives, on the other hand, offer more predictable mechanical behavior with much lower backlash and higher torque capacity. They're also more durable under heavy loads and repetitive motion, which is ideal for humanoids expected to operate continuously in dynamic environments. For Foundation Robotics, this consistency between simulation and real-world performance is a game-changer. It means fewer surprises during deployment and faster iteration when developing new capabilities. Sankayet emphasizes that while cycloidal gear systems are slightly bulkier and more complex to manufacture than harmonics, the trade-offs are worth it. Not only do they help reduce wear and tear over time, but they also enable a level of control fidelity that aligns better with modern reinforcement learning and imitation learning techniques. In other words, you can train your humanoid to perform a task in simulation with high confidence that the real robot will replicate it just as well, without the need for extensive fine-tuning or hardware compensation layers. This move is part of Foundation Robotics' broader philosophy of building humanoids that are both mechanically efficient and software-friendly. It's not just about raw strength or agility. It's about creating a development pipeline that is scalable, repeatable, and grounded in engineering realism. And by investing in more stable and predictable actuator technology, the company is laying the foundation, quite literally, for faster progress in embodied AI. If this approach catches on, it could signal a shift in the humanoid robotics landscape. With more teams prioritizing sim-to-real fidelity, mechanical design might start to evolve in tandem with software architecture, rather than being treated as an afterthought. And Foundation Robotics, with its cycloidal-driven humanoids, is already a few steps ahead in that direction. Iron has officially made its debut at the Shanghai Auto Show, and XPeng isn't just showing off its cars this year. They're showcasing the future of intelligent mobility in humanoid form. The company's highly anticipated bipedal robot arrived in dramatic fashion, transported in the back of an XPeng X9 electric minivan, merging sleek electric vehicle design with advanced robotics in a single moment that says a lot about XPeng's future ambitions. But once Iron stepped out of the van, the focus quickly shifted to the robot itself, and for good reason. This wasn't a stiff or tentative demo. Iron walked with a smooth, confident gait that immediately caught attention. Unlike many humanoids that still struggle with unnatural or jittery motion, Iron's steps looked purposeful, composed, and most importantly, controlled. And it's not just about aesthetics. There's real engineering precision behind how this robot moves. One of the standout technical highlights at the show was how XPeng has designed Iron's RAF hip joint, specifically the R actuator, to dynamically assist with turning. When Iron changes direction, the R actuator doesn't just pivot the upper leg. It reorients the entire knee and foot, pointing them cleanly in the new direction of travel. That might sound like a small detail, but it's a huge deal in robotics. Most humanoids turn by shuffling or awkwardly rotating their whole body. Iron, on the other hand, shows off a motion sequence that's more biomechanically sound, more energy efficient, and much closer to how humans actually walk and turn. And this is where the importance of the R actuator becomes crystal clear. In most hip designs, especially in early-generation robots, the rotational element is either underutilized or not tuned precisely enough to play a leading role in locomotion. But in Iron, it's front and center, literally guiding the robot's leg orientation to ensure smooth direction changes. It's not just helping with motion. It's redefining how motion planning is executed in real time. This actuator isn't just part of the hip. It's directing the whole leg's trajectory, enabling Iron to maintain stability and fluidity while changing course. The Shanghai Auto Show appearance wasn't just a PR moment. It was a milestone that signals XPeng's serious entry into the humanoid robot space. By delivering a demo with this level of polish, one that blends mechanical sophistication with real-world usability, they're showing that Iron isn't a one-off prototype. It's the beginning of a larger robotics vision integrated with their existing ecosystem of smart vehicles, autonomous driving, and intelligent control systems. The message is clear. In XPeng's world, cars and robots aren't two separate paths. They're parallel tracks of one evolving intelligent mobility platform. And with Iron's public showcase, XPeng just gave everyone a preview of how far that vision has already come. Red Rabbit Robotics has unveiled its latest humanoid robot, the RX 2.5, demonstrating significant advancements in dexterity and precision. In a recent pick-and-place demonstration, the RX 2.5 showcased its ability to handle objects with remarkable accuracy, highlighting its potential for tasks requiring fine motor skills. The RX 2.5's design emphasizes strong hand coordination, allowing it to perform complex manipulations with ease. This capability is crucial for applications in manufacturing and logistics, where precise object handling is essential. The robot's performance in the demonstration suggests a significant step forward in humanoid robotics, particularly in tasks that demand a high degree of dexterity. Red Rabbit Robotics continues to push the boundaries of humanoid robot capabilities, aiming to create machines that can seamlessly integrate into various industries. The RX 2.5's latest demonstration serves as a testament to the company's commitment to advancing robotic technology and its practical applications in real-world scenarios. Booster Robotics T1 isn't just playing soccer. It's redefining what humanoids can do. At just 4 feet tall, T1 from Booster Robotics might not tower over the competition. But when it takes to the field, it stands tall in a whole new way. For the engineers behind T1, soccer isn't just a clever party trick. It's a proving ground for something far more ambitious: true, dynamic human-robot interaction. In a recent demonstration that caught the attention of robotics enthusiasts worldwide, T1 was seen dribbling, passing, and even balancing with the kind of control you'd expect from a skilled athlete, not a machine. And while it's easy to be wowed by the novelty of a robot playing sports, Booster Robotics has a deeper purpose in mind. The team sees locomotion and coordination, especially in complex, unpredictable environments like a soccer field, as critical milestones in building robots that can one day thrive in the real world. That wraps up this week's AI Robot Update. And honestly, every week feels more like science fiction turning into reality. With robots evolving faster than ever, the line between human and machine is starting to blur. We'll be tracking every mind-blowing moment, so make sure you're following along. Trust me, you do not want to miss what's coming next. Thanks for watching, and we'll catch you in the next one.